All right, so I'm going to talk about some stocks and cryptocurrency time series data prediction using LSTM. So that this is like kind of conceptual. So you would have to have like more robust models, but the idea that you can do all of those kind of things is like using the computing power that you can at least like can have reach to normal or average people or average investors in order to have to perform them at least. So I would like to go like some tutorials here. So first of all, we will add the data from here. We can have like automated script that get the data, but I prepared the data. So this is in my private data set. This is the stock ticker from Yahoo Finance. For example, S&P 500. Let's go and see. This one is the stock of AIO, which means yeah, Tinto. This is like one of the largest mining applications in the world. Maybe we should have. And first thing we got to do is like importing library imports that we should import libraries that we will use in our purchase. So first of all, we have cost directory, and we have import NumPy as usual. That NumPy is like main library for Python, especially the numerical data, and also import and also we have pandas for tabular data for analytics. So this is like one of the most used data library on Python, and also let's import this one and from we let's skip this this one first, and also I have libraries here like beside me, so I look at them and see what kind of libraries we are in. So sklearn and p16 and just let's use up-to-date LSTM and import this. The reason why I'm using those two libraries not will be used on those, but the reason that I'm using those is because you need to run on your local computer, where you need to work with your local computer file system. So in order to use work with the file system, you have like two really good libraries that you can use. Here, so now let's go down, and then first thing is like let's try to import. We can run. So we have here the data. So we can copy the path and data pt csv. We can paste the paste the path and index equal to 0, which means like the first column will be the index column, and also we will parse the dates. So we parse the data, then we will show the data sheet and also data. So basically we have data start from 1990 and also data we have this one. And what we will work on to predict the data is the adjusted close. So first thing we got to do is make the secret training data. In order to predict the next adjusted close, we will have all adjusted close. So first thing is like we will prepare the training equal to data and let's do that. Values means we are getting all the values, not the table info. Like it just close will not be in the data, but to the array with the column, all the column info. So then from now on, the important thing is like scaling the data. Scaling the data. It's like we will have a chance to scale the data into 0 to 1 rate that we can have like simpler and also like not biased computation, and also that computation would be like kind of efficient for the CPU that or GPU that for the process. So we can scale the data. So first thing is like as we know that we imported this, so we will declare our schedule using min max schedule and feature range to 0. So we have this schedule, and now what we will do is training schedule P transform. So basically we are scaling this table into 0 to 1 range, which means like maximum of the just close will be 1 and minimum of it will be the 0. So we are scaling to have better computation, and also it will be like better potential. So let's do this, and second thing is we need to prepare what kind of training and testing data. So first thing is let's just do first this one. Then first thing is like we have testing scale to training scale. Since our data has around 7,000 records, so we will basically find can select like proportion of them. So in our case, let's just choose 59, maybe 60 from this. And this is testing skill. Basically, like we are getting last 460 data for testing our testing networking, testing the model, and also we are going to training. Now we can use, since we use this one, so we don't need this anymore, this structure anymore, so we can use this. So training scale, and also we selected this one. to minus 400, which means now what we should do is we select top data that we will train minus up to minus 400, which means like our training data will be 1,200 records. So we will go to this and let's see. We will make it. I think this make the markdown. This kind of the partner node that you can prepare for your development process. So this is kind of the advantage of the Jupyter notebook. So first thing is let's try and and so we have 146 and 460 and 1,200 data points that we have collected. Slice it from all the data that, like, we just expecting that only this much data will be like useful for our prediction of next price of the adjusted close on this particular set. So let's go down and now what kind of thing that we usually do in this case is like we will prepare training data and testing data. So first thing is basically I already worked on those, so I will just new scale. We will use the above two variable that we sliced out. So testing. Okay. So first thing is we will create this trend with this thread and white trend. So for the reason why we get this one, because we want to predict using last 60 days to next 1 day. Like we will have like kind of the 60 days of data can define the next day. Kind of that based on that concept, we are developing this. So from here, we can go like this, point green. Training scale. The reason why we are starting 60 is like here, basically we have to have the data in each row with the length of 60. So this will be the reason that we are again minus 60 and y and 0, which means like we will get the 60 column and 0 element, which means like each cell, each row has like one element. So the first element of the cell is 0. So 0 will be taken and into the row converted into the row, like coded into that. So our second thing is we have trained the our next point will be like this, and basically we will also have like 0 here. So then now we will have this and this. So very similar to this. We just copy this. The reason why we're using this one because we get some data inside the training in order to predict inside the data inside the test. So we get that. There is no problem. So whatsoever. So we can continue on that. And now what kind of thing we should do is in order to make our use like simpler, we can convert our data into the NumPy array that we imported the NumPy library. That's the main use of that. So first thing is we will have its train, its this, and basically. Then what we will do is we need to reshape our string to np.shape. This will be explained later, but it's just reshape it string and basically we will reshape this and this, we will do this, and we will have here we have x this. Let's just make this bigger. To get train this. Now we can show our we will have our data, which means like this one, and this one has to match, and also this number and this number should match, like in terms of picture and also in terms of text, so target. So now the thing is that we will build the model. So in order to build the model, we will declare the model function, and inside that we will declare sequential deep learning model and LSTM. So our first layer is LSTM with units of 200 and and Orchid. So this is the shape that this has to match with this one. This shape has to match with this one. And we will have like 2 units, 200 units, means 200. And we will return sequence, means we will return the sequence and also we will have this. Okay. I just add 200. This is really common practice that adding like more sequence would be like better and smooth, makes smoother the data. So let's just so we don't need to input shape because we already imported. Okay. So it's inside the network, so we don't need that. And also here we got LSTM. We need this 100. True. And also we got and sequence annotate inside, which means this one is the output. We will return the inside which unit one, which means our output. Then we will try to notice edit obtain here and so we can do like this. And basically this one is down. So we will take them out this and model summary. We will see what so we have model with lots of 60,100, 60,100 and 80, 300 and one total parameters, trainable parameter upset. And now it's the purchase that you can start train your model. So sorry. The reason why I'm getting the history is because I need to have some knowledge about what kind of things were happening during my training process. So train and write train and box. We will train and the box and website means we will select each time packets of rows, which means like 60 rows each time from the training data. For example, in this case, it's 60. And we can start training here, but before we start the training, we can do one thing. So we can do this, turn on the GPU, which means like I have the GPU code of 43 hours every week. So I can use this now. And the important thing is you need to install it. Now let's just install and wait. So this is lots of data, and it was not taken. This is something. So now we are almost going to done, but since here, I think all right. So our installing has just been completed, so we can comment this out and let's restart our finish. Start our session because we installed new button, new TensorFlow. So important thing is let's just import TensorFlow as here, and let's see here what version has been installed. So we can see this, and after every purchase is same, and we'll just go down and see like what kind of things we have been seeing so far. And yeah, the model as shown the model. Yeah, we got the model. So now we are starting to train. So this one takes like super long. For example, this is using like 15 gigabyte or 16 gigabyte. And yeah, this is going down super fast. So what we can do now is we can stop here and let's prepare for our next thing. So while it's learning, to get in training, we can prepare the kind of things like take training. So which means that gets the history that we declared in order to get what kind of data that is history. And now we are making use of our library that we declared as a matplotlib. We are going to use that library to plot some performance features on there. And let's just take it. See division and this is the process that the operating model has been turned and also ready. This is basically the loss, how it's increased, and with the will show, and then we will now we are seeing that the from starting from 0.3, the loss has been increased significantly, something like 0. But since we are still the numbers, so we can't get like what kind of how good the error would be. So we will go forward and also inverse scaling our initial data. So get then I will get X test and it means like we are predicting our model, this one, to using X test to get the prediction about each model. Now we have predicted this to scalar dot use. We basically can have same name because we don't need to use like declare like different variables in terms of memory. even though it's not significant, we just use this because this variable will not be like any useful in the future, that we can just invert this and assign this into that. So like that. And now we have prices. Basically, prices is like real prices. So scalar dot inverse transform. Then we just put the whitest. The thing that we need to do is we have to put it additional bracket in order to make this into 2D array. So this is how it's done in the beginning. This and now this now we can build show so in order to have a better insight about how we can build our predicted prices. So prices, predicted prices, and the reason why we are using the index is like we want to have like data like time series on our graph. Then let's just go and I will explain like why we are doing that kind of thing. So basically, then now we are going to talk what we have developed so far. The reason why we are doing this one is because it would be like much simpler to build like our graph on time series that we can use like any kind of stock or time series data that we have same named column and also same shape data with same shape or something. Like so now what we are going to do is this result dot plot basically plot template into CNAD slash audio. Right. It is All right, now we are seeing that the prediction results is predicted price is kind of this that we are seeing what kind of difference, and also the real price and predicted price was how it was affected in the meantime time series. The model is basically trying to use like all the next using like last 60 days of data using next day, like 61 day, 61st day price would be predicted. So from here, what I will do is next, I will next is like I will put some methods for you to look what is your data for the future. If you can use like several functions to predict the future price, but how you can display or something like that will be recorded next time. And this we have been learning to predict kind of how we can use the time series. So I will share this one to public, and also make this video on share this link under the video. So thank you so much for going through my tutorial and learning about it, and I hope that you will enjoy it. And also please ask any questions related to this kind. Also, I'm super open to the suggestions, and also the most important thing that I'm really interested in this time series data analytics, especially in finance, is like I really try to get like some better performing models to build at least like good performing model to build have like better profit on cryptocurrency trading and stock market trading. So it will be like super nice that you will have discussion about this with me. So thank you so much for watching the video, and I hope you will enjoy this. So good luck for your journey to learning, deep learning, and also using LSTM for prediction of the market data. So thank you so much, and good luck for your journey. And please ask any question.